हेलो फ्रेंड्स। आज के वीडियो में हम डिस्कस करने जा रहे हैं केमिस्ट्री ऑफ ओजोन फॉर्मेशन। उसको हम चैपमैन रिएक्शन के नाम से भी जानते हैं। सो ये वीडियो जो भी कैंडिडेट्स और जो भी स्टूडेंट एनटीपीसी असिस्टेंट ऑफिसर इन्वायरमेंट मैनेजमेंट की जो वैकेंसी निकली है उसकी तैयारी कर रहे हैं, प्रिपरेशंस कर रहे हैं, उनके लिए काफ़ी इम्पोर्टेंट है। तो चलिए वीडियो को स्टार्ट करते हैं। फर्स्ट ऑफ ऑल, ओजोन। So what is ozone? So ozone is also known as trioxygen. It is an organic molecule, inorganic molecule having the chemical formula O3. So there are three atoms of oxygen in the ozone. कई बार एग्जाम में क्वेश्चन पूछा जाता है व्हाट इज द कलर ऑफ ओजोन गैस। सो द कलर ऑफ ओजोन गैस इज द पेल ब्लू गैस, light blue gas. The color of ozone is the light blue, and the ozone having a distinctive or a specific pungent smell. So this is very important. Ozone having the color as well as smell both. So it is an allotrope of oxygen, okay, which is less stable than the O2. So oxygen is the allotrope of ozone is the allotrope of oxygen, which is less stable than the oxygen. So this is the molecular structure of the ozone. Here you can see the bond angle between the ozone and ozone atoms is 116.8 degree, and the bond length is the 1.278 angstrom. चलिए अब डिस्कस करते हैं कि ओजोन की डिस्कवरी किसने की, नाम किसने दिया, इसकी नेचर कैसी होती है। सो हु डिस्कवर्ड द ओजोन लेयर, ओजोन गैस? So Christian Friedrich Chopin in 1839 discovered as well as named the ozone. तो ओजोन को खोज किसने की और नाम किसने किया, नाम किसने दिया? क्रिश्चियन फ्रेडरिच शोपेन in 1839. So ozone word is originated from a Greek word ouzine, which means to smell, because ozone having a specific pungent smell. So this is the picture of Friedrich Chopin, who discovered as well as named the ozone gas. Ozone is a secondary pollutant. So what do we mean by secondary pollutants? So primary pollutants are the pollutants which are directly emitted from a particular source. But the secondary pollutants are the pollutants which are having no direct source. They are formed in the atmosphere when the primary pollutants reacts with the water vapor in presence of some sunlight and UV radiation. So ozone is also a well-known example of the secondary pollutant. When we celebrate the World Ozone Day, 16th September, and it was started from 1994. What is the average concentration of ozone in the India? So the concentration of ozone is highly variable, but in general we can observe 20 to 45 ppb, part per billion concentration we can record in India. According to United Nations study in 2018, they show that ozone level is recovering at the rate of 1 to 3% per decade. So according to a UN study, the ozone layer, this is about the ozone layer, is recovering, means the ozone hole is reducing at the rate of 1 to 3% per decade. Then after, who discovered the ozone layer? In 1913, the ozone layer was discovered by the French physicist Charles Fabry और हेनरी बुइसन. सो याद रखना, ऊपर हमने ओजोन गैस की बात की है और ये है ओजोन लेयर. देन आफ्टर, हु डिस्कवर्ड द ओजोन होल? वेरी इंपॉर्टेंट. हु डिस्कवर्ड द ओजोन होल? द ओजोन होल डिस्कवर्ड बाय द जोनाथन फ्रैंकलिन, जोसेफ फारमान व ब्रियन गार्डनर. तो कई बार एग्जाम में केवल फार्मान का नाम ही लिखा होता है, तो उन्होंने ओजोन होल की खोज की। तो चलिए एक बार दोबारा से हम इनको डिस्कस करते हैं। ओजोन गैस, सबसे पहले हम बात करते हैं हु डिस्कवर्ड द ओजोन गैस। क्रिश्चियन फ्रेडरिक सोबेन इन 1839। Who named the ozone gas? Christian Friedrich Schopen. So discovery or named by given by the same scientist. Then after ozone layer, who discovered the ozone layer? In 1913, the ozone layer was discovered by Charles Fabry and Henry Boyson. Then after who discovered the ozone hole? The ozone hole discovered by the Franklin, Joseph Farman and Brian Gardiner. So याद रखना ये स्लाइड काफी इंपॉर्टेंट है। Now the atmospheric transport of ozone from equator to pole is known as Brewer-Dobson circulation. So this is the earth and this is the equator. These are the poles. Okay. So the transport of ozone from equator to poles is known as Brewer-Dobson circulation. The total ozone mapping spectrometer TOMS. So TOMS is a instrument that used to measure the ozone concentration. Okay, so we implant this instrument on the satellite to measure the ozone layer thickness. So there are many satellites who carrying the TOMS instrument like Nimbus 7, very well known or very famous satellite. These are the name of satellite: Nimbus 7, Meteor 35, Edios 1, TOMS Earth Probe and Quick TOMS. So these are the name of satellite and TOMS is a name of instrument. Basically this is a spectrophotometer. So that there are other spectrophotometer, they are also used for the total ozone concentration measurement like Dobson spectrophotometer and Brewer spectrophotometer. So some other satellite were also launched by the European Union like EU MedSat METOP A in 2006 and METOP B in 2012, that carrying another instrument that is known as GOM2. The earlier one having the TOMS and these satellite having the GOM2, the Global Ozone Monitoring Experiment, which are also used for the measurement of the ozone in the upper atmosphere. Now the ozone in the Earth atmosphere. Okay. So basically now we are going to discuss about the measurement, how we measure the ozone. So the total ozone basically measured in a specific units that is known as Dobson unit. Very common and very well known, and you are very familiar with these units, Dobson unit. So sometime you got confused with the uh, Dobson unit and decibel units. Okay, so Dobson for ozone and decibel used for the noise pollution measurement. So some other units are for the ozone concentration measurements are the mm, normal mole per mole. Okay, we can say these are the ppb and microgram per cubic meter. When we are measuring the ozone concentration at a specific point, then generally we use this type of the unit like microgram per cubic meter, ppb. So what is the one Dobson? Very important. Okay, so one Dobson is a unit, or we can say the number of ozone molecule that would require to create a layer of pure ozone 0.01 millimeter thickness at a specific temperature of 0 degree centigrade and 1 atmospheric pressure. So one Dobson is a one Dobson. One Dobson is equal to 0.01 mm thickness of ozone ozone layer at 0 degree centigrade and 1 atmospheric pressure. So these are the some specific conditions for defining the one Dobson. So how many molecules can retain in one Dobson unit? So the one Dobson unit of ozone contain 2.69 into 10 to power 16 ozone molecule for every square meter centimeter of area, every square centimeter area contain this much of ozone molecules. So generally the ozone layer thickness is 300 Dobson unit. So 300 means 1 Dobson unit is equal to 0.01 mm. So 300 Dobson unit कितना हो जाएगा 3 mm. So हम कह सकते हैं कि the thickness of ozone layer is 300 Dobson unit or 3 mm thickness. So this is the thickness of ozone layer. You can imagine this is the thickness of two coins when we put on each other. So the thickness is 3 mm, and the thickness of ozone hole, when the ozone got depleted, in that time the thickness is reduced from 300 Dobson to 100 Dobson, or we can say 3 mm से डिक्रीज होके 1 mm thickness हो जाती है in case of the ozone hole. When the thickness is reduced, this condition is known as ozone hole. ओजोन होल का मतलब ये नहीं होता है कि ओजोन लेयर में कोई होल हो गया, वहां पे ओजोन जो लेयर है उसकी थिकनेस कम हो जाती है. दैट इज नोन एज ओजोन होल. नाउ द ओजोन क्लासिफाइड इनटू टू कैटेगरी, गुड ओजोन एंड बैड ओजोन. When we see on this is the earth, on earth surface, this is the troposphere, this is the stratosphere. In stratosphere there is a ozone layers, this is the ozone layer. So whatever ozone present in the ozone layer, or we can say stratosphere, that is known as good ozone. But whatever ozone present in the troposphere, that is the bad ozone, because it is a strong oxidant and it having the harmful effect on the living beings, on the plants, on the properties, everything. So that's why it is known as bad ozone. And the ozone present in the stratosphere or ozone layer, because this ozone protect us from the UV radiation. That's why this is the good ozone. Now the ozone concentration. Okay, so in general, what we think, what you think, the concentration of ozone found higher in the urban area or in the rural area. But we think that the concentration may be more in the urban area because there is more pollution, more pollutant. But this, you can see this picture, this diagram. Here you can see upper one, this the red line and the blue line. The red line showing the background rural concentration of ozone, and the blue line indicating the urban background concentration of ozone. And the data you can see, these are from 1987 to till now. When we see the background concentration, it was found higher in the rural areas. Why? So this phenomena, when the concentration found higher in the rural area as compared to the urban area, this is known as ozone paradox. So there are one important factor behind this. What happened? So how the ozone formation take place? When the oxides of nitrogen are present in the atmosphere, they react with volatile organic carbons, or we can say sunlight, and they form the ozone. This is a general reaction of ozone formation in the troposphere. Okay. In urban area, what happened? In the morning time when the traffic intensity rise, so the more traffic means more emissions of the nitric oxide, NO. When the traffic is, or automobiles or vehicles are more, then the more NO emission take place. Okay, during the traffic time, this NO react with the whatever ozone present in the atmosphere. So when the NO react with the ozone, what they form? NO2 and oxygen. So there is the disintegration of ozone into oxygen. Okay. But when we see this reaction in the rural area, in village side, see there is very less amount of the traffic, or we can see number of vehicles are very less compared to the urban area. So there is less amount of NO. So less amount of NO, so less reaction with the ozone. So less O2 formation, or we can say less disintegration of the ozone. So that's why the ozone concentration retain more in the rural area as compared to the urban area. Now, when we see the radiation spectrum, so you all are aware about the radiation spectrum, but we see when we go from the left side to right side, see this is the gamma radiation, X-ray, UV ray, this is the visible, infrared, and radio wave. So this is the infrared, this is the radiation spectrum. Okay, so when we go from gamma radiation to towards the radio wave, you can see the wavelength is continuously increasing, but the energy is continuously decreasing, because when you see the this equation, E is directly reversely proportional to the lambda. This is the wavelength, or this is the energy. When the wavelength is increasing, the energy is decreasing, or vice versa. So here you can see UV radiation, because the ozone layer protect us from the UV radiation. So the UV radiation having the wavelength from 100 nanometer to 400 nanometer. After 400 nanometer to 700 nanometer is known as visible light. This is in short VIBGYOR. So visible light is very important for the plants. So this 100 nanometer to 400 nanometer spectrum again is classified into three categories. Basically, we can say UV radiation are classified into three categories: UVA, UVB, or UVC. Here you can see UVA, UVB, UVC. So whatever light that are near to the visible light, they are known UVA, then after UVB, then after UVC. So the UVA light having the wavelength from 100, UVC light having 100 to 280, UVB having 280 to 315, and UVA having 315 to 400 nanometer. So here you can see this is the from UVC. When we go from UVC to UVA, so the wavelength is continuously increasing, but the energy is decreasing. The energy is decreased, it means the UVC having the higher energy compared to the UVA. That's why the UVC radiations are most harmful, or more harmful compared to the B and C UV radiations. So here you can see whatever sunlight reach on the Earth surface, in which 5 to 6% are UV radiations, and in 5 to and out of 5 to 6% UV radiation, more than 90% are contributed by the UVA radiation, and the remaining UVB and C is captured or absorbed by the UV radiation. So, ozone layer. So here you can see there are three type of UV radiation. These are we already discussed. Here you can see. So here we already discussed the UVC radiation are the having the short wavelength but having the maximum energy. That's why they are most harmful UV radiations. And due to the UV radiations, there are tanning effect, skin aging, cancer, wrinkles on the skin. These are the some harmful effect can be observed on the skin. So here you can see in this picture, this is the troposphere. Okay, so most this is the UV radiation. This is the ozone layer. So here in ozone layer you can see more than 90% UVA radiation reach on the Earth surface, but only 90% UVB radiation reach. Most of the UV radiation cross and come on the Earth surface, but 90% UV radiation is absorbed by the ozone layer, and only 10% UV radiation reach on the Earth surface, UVB radiation. And or we can say more than 99% UVC radiation absorbed by the ozone layer. So the UVC radiation reach very less. But when there are ozone hole formation, means the thickness of ozone layer is very low, reduced. In that case, UVC radiation also reach on the Earth surface. That's why there are more chances of the skin cancers. So here you can see 99% UVC is absorbed by the ozone layer, more than 90% UVB, and almost 50% UVA radiation are absorbed by the ozone layer. Now, how the ozone formation take place? So, in the presence of sunlight, when the oxides of nitrogen react with the volatile organic carbons, they form the ozone. This is a general reaction. Now, how the ozone formation and destruction take place? So, when the ozone continue, there is a continuous cycle of ozone formation and destruction, and this cycle is known as Chapman cycle, or we can say Chapman reaction. So, this is the uh, Sydney Chapman who discovered the Chapman cycle or Chapman reactions. So, here you can see these reactions are proposed by the Sydney Chapman in 1930, and Chapman explained how the ozone formation and destruction take place in the stratosphere. So the ozone formation or destruction reaction, or we can say Chapman reaction, started with the photolysis of molecular oxygen. It is very important. Keep in mind, the Chapman reaction start when the photolysis of molecular oxygen start. Okay. So at earlier stage, when the UV radiation of wavelength 240 less than 240 nanometer, they absorb by the oxygen molecule. The UV radiation less than 240 nanometer, they are absorbed by the oxygen molecule, and this oxygen molecule split into two oxygen atoms. These oxygen atom again react with the oxygen and they form the ozone molecule. Okay, so here you can see the oxygen molecule when the UV wavelength of UV radiation less than 240 to 42.5 nanometer, they form two oxygen atom, and these oxygen atom again react with molecular oxygen and form the ozone. Okay, the ozone converted back into the oxygen when the UV radiation of wavelength less than 308 nanometer. When the UV radiation having the wavelength 308 nanometer, they react with the ozone and form the molecular oxygen and atomic oxygen. Again, this ozone, whatever ozone present there, that it react with the atomic oxygen and they form the oxygen. So this way, initially the photolysis of oxygen started, and finally again the oxygen produced. So this is a cyclic reaction and continuously going in the stratosphere, and these reactions known as Chapman reactions. So this is a picture of ozone effect on the plants. You can see when there is a severe exposure of ozone, the condition of leaf of the plant, you can see this is the very destructive effect of the ozone on the plants. सो फ्रेंड्स, थैंक यू सो मच। आज के वीडियो में इतना ही, अगले वीडियो में फिर मिलते हैं, तब तक के लिए नमस्कार।